Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. At this point, we've covered a number of different commands for the Linux command line. We started with things that dealt with manipulating files and directories. We've looked at things for remote access, encryption, decryption. There's still a whole lot of other commands, and in fact, there are so many commands that we can't possibly cover them all. But for this video, I kind of want to present a smorgasbord of other commands that I have found useful at various times and run through these. And between this lecture and the next one, hopefully you'll see how you can utilize some of these and put things together to get a little bit more power out of the command line. So we'll open up the terminal. Once again, when you do it that way, it starts you off in desktop, so I will go back to my home directory. And the first two commands that I want to talk about here deal with disk usage. So the first one is called df, and it stands for disk free. It shows you how much space is free on the current disk. Now, of course, this is inside of the virtual disk that I have set up for VirtualBox, and I set this up so it's supposed to be a 100 gigabyte disk. So it tells me the information for what device it is. It tells me how big it is, how much of it's currently being used, what is available, and what percentage is being used, as well as the path for it. So the main disk is mounted as slash. There are a number of other things that are listed in here that are kind of temporary or RAM disk type of items. If you run this on not the virtual install, but a real install, or if you're on a separate Linux install and you do this, you might see other things. If you were to plug in, for example, a thumb drive, or if you put in an SD card or something like that, that would pop up here. And one of the advantages of DF isn't just to show you how much free space you have, though there are times where it's very good to be able to monitor this. It can also help you see where things are mounted. So if you were to put on a thumb drive and you don't want to just click around on stuff, you actually want to be able to interact with it on the terminal because, for example, you wanted to easily copy 100 files with different names or something like that, something that you could do easily from the command line that might be hard to do from the GUI. Well, you could you would need to know where it was mounted, and DF will tell you that. It will tell you how to get to that thumb drive. The opposite of telling you how much disk is being utilized for the whole space, or how much disk free, would be disk usage, and that's a command called du. Now du tells you how much space is being used in individual directories, and if you just run it by default, what it does is it goes through every directory in your current path and then everything under that and everything under that, and it prints it all out. And so you can see all of these different directories that are listed here. Over here is the amount of space taken up by that directory in kilobytes, and at the bottom here you can see that the dot directory is taking up 600 megs, 620 megs. You can also tell du that you just want to do a particular directory, like if I just want to do the .swt here. This says that .swt is using 56K, the lib directory under that is 52 of it, the Linux directory is 48, and that is 44. So you can get that type of information. The problem is that this printed out so darn much stuff that it might not be helpful to me. A lot of times all I want to know is how big is each of the directories one under my current location. And so the option that I use most in du is max depth. Okay, and this tells it how far down the directories to go. So if I say a max depth 1, it'll only print out the information for one directory down. Now it'll add up all the space being used by subdirectories, but it won't print them all out for me. So this gives me the ability to see that most of the space here is being taken by the install of Eclipse, the install of Java, and a little bit by the Scala install on here, and that's what adds up to this size. If you happen to be on a different system or you need to delete things, it's generally helpful to delete the biggest files. Turns out that you can totally axe your .config, not that you want to, and it wouldn't make much difference down here. If you wanted to really free up space, you have to hit the big directories. If you are working on like a school system and you have a managed account, you might also have limits on how much disk space you can use, what's called a quota. And so, for example, on the Trinity machines, there is a command called quota. It won't work here because it's not installed here. And that will show you how much space you are allowed to use and how much space you are currently using. If you start to get close to your quota, or if you go over your quota, it can do bad things to you because files will no longer save. And using du with the and specifying a depth to it can help you see where you are using a lot of space, and that way you can delete things that will actually benefit you and reduce your disk usage. When we looked at the contents of files, we used commands like cat or more or less, and you might recall from the last video that we downloaded this file called log. Log is a very significant file. It's 106 megabytes. So for example, if I just cat log, it will go for a very long time. And I need to Control C to get out of it. I could less the log, but once again, there's a lot of stuff there. What if the only thing I cared about was like the end of the file? And it turns out that that log comes from simulations that I run, and a lot of times all I do care about is the end of the file. Well, there is a command called tail where you can look at just the end of the file. So if I tail log, by default it gives me the last 10 lines. If I wanted to see more, I could do something like tail-20 of log, and that'll give me the last 20 lines. The counterpart to tail is head. So instead of doing tail of log, if I head log, I will see just the first 10 lines, and I can also pass it an option to see more. So if you only want to see the beginning or the end of something, head and tail are commands that will give that to you. In and of themselves, there probably aren't too many situations where you want to use them, though there definitely are some, but we'll see in the next video that they can be combined with other things to be more useful. Now, the next command is a command called touch. And to understand what touch does, we need to remember what the various information we have about the different files. So we have their permissions, we have who owns them, we have their size, we have the date of the last modification, and we have a name. What touch does is it updates the modification date. So it says, okay, I'm not going to change anything about this file or this directory, but I'm going to make it so that it is modified now instead of in the past. And the reason you would want to do this is occasionally there are things that decide whether or not they will do certain processing based upon whether or not the file has been modified recently. And so if you want to say that a file has been modified recently, but you don't actually want to change anything in it, you can use touch. So for example, if I touch log and then I do this again, you can see that now the time on log has been updated, and so it's about half an hour later than it was. You can also touch a file that doesn't exist. So if there is no temp here, so if I touch temp, what that does is it creates a new file that has the current time as its modification time, and it's empty. It doesn't have anything in it. I can use rm to get rid of that because I don't really need that file sitting around. What if you want to find files? So this is something that you probably do a lot on your computer. You don't remember where some file is, or maybe it's a file you've never known where it is and you need to go looking for it, to do a search, or to find it. Well, the Linux command for this is indeed called find. And when you run find, you have to tell it the directory that you're searching under. So for example, I want to search under the current directory for things. And if I know exactly what the file is called, so if I were searching for log, of course it's in the current directory, so I don't need to be searching for it. Or how about I do this, eclipse.ini. If I can't remember where the ini file is, I could do a find on it. Oops, sorry. Left out the hyphen name. There are actually lots of options for find, and so you can do a man on find and see all of these options. You can search by how big the file is, so you can look for big files or little files. You can search for files that have been modified within a certain amount of time. There are lots of different options, and the man page will list all of them. Quite honestly, the only one that I use on a regular basis is name, because I'm looking for a file by name, or I'm talking to a student and the student says, I have a file named blank and I don't know where it is. Well, then we'll do this. What if I, instead of finding a file by a particular name, I wanted to find all of the .png image files? Well, we could say that in the command line by doing star.png, because that star, remember, is a wildcard that can stand for anything that you want. The problem here is that if we just pass it like this, the star gets expanded right here, and this becomes all files that end in .png in the current directory, which is nothing. If we don't want it to be expanded, we need to put quotes around it. So I'm going to say find.-name, and then inside of quotes, star.png, and this will go through and it'll find all the PNG files for me. And what you can see is that there are actually quite a few of them. The Java install, the Eclipse install, a number of the programs that I've installed have PNG files as part of their install. So you can use a command like this to go searching for things. We can look for a different type of image, GIF file. Once again, there are quite a few of them in the things that I installed. So find looks for whole files under a particular directory. What if you want to search inside of a file? So what if I wanted to go looking through that log file and I only wanted to find certain things? Well, of course, I could bring up less and hit slash to do a search and then hit N to go to next, next, next. But you can also run a command that will only print out lines that contain something, and that command is called grep. So grep does a search inside of a file for something. So now it turns out that the log file has a lot of numbers in it, and just because it's so remarkably long, you would expect that the sequence 1, 2, 3, or 1, 2, 3, 4, having those 4 digits in order will actually occur a fair bit. And so if we grep for that inside of log, you can see it indeed does print out quite a bit. The grep here is highlighting the matches so that you can easily see where they are in there. So that's one usage of grep. Now, of course, that was just kind of a play one. Why I use grep a lot more for these types of files is every so often the simulation prints out what step it's on. And so you can grep for step in there, and you can see that's a number. Of course, there are lots and lots and lots of them in there. So that's one of the places where we'll see we might want to combine it with a head or a tail so we can only see certain parts. So grep does searching inside of files for us, and you could specify multiple files that you want to do the grep inside of instead of just a single one. There are also commands that let you know what is running on a machine. So the first one is PS, okay, and this takes kind of a snapshot of what processes are running. If you just run PS by itself, it will show you what is running in the current terminal here, so what you've started running. Bash is the command processor, which is itself a program, and of course, while PS is running, PS is there. And so it lists these two for us. If I had started some other things running and put them in the background, they would also appear in this list. You can pass PS a whole bunch of different options, one of which is the -EF. And what -EF does is it tells it to print all of the things that are running and use a longer format for it. So one of the interesting things to note here is that even though I'm not doing much on this particular virtual machine, there are lots of processes running. And this shows me who is running them. So a lot of the processes will be run by root. Since I'm logged in as student, a lot of them are run as student. There are occasionally other usernames that have been set up to run particular types of programs. You have what's called a process ID, and that process ID is a very significant number. It's how you refer to processes. And then you can also see what command it is that's being run out here. One of the reasons why you might want to know a process ID of something would be so that you can stop it. So for example, there is a command called kill, and so I could kill 1312, which right now, since that was the PS and the PS is stopped, it says there isn't one of those anymore. But you can use kill to stop jobs that might be running in the background. Kind of a more interactive way of looking at what's running, and in particular what's taking up the most resources, is to run top. And the top command lets you see the top processes, and by default it's showing you the ones that are taking up the most CPU usage in here. It also gives you memory usage, it tells you load and stuff like that. Top is a very handy program for looking at what's going on a machine and what's consuming resources for you. There's also a command called W, and W lists out everyone that's logged on a machine and gives you some of the information for the top, and it tells you what they're doing. So if you happen to be remote logging into a machine and it's running slow, you might look to see what other users are there and if they are doing things that are perhaps processor intensive. Lastly, there's a command called wget. And so wget is actually a program that pulls something off of the web for you. So if you know the URL for a website, so for example, I want to pull down the main page for Google, I can say wget that, and when I hit enter, prints out a lot of information about how it was connecting and such, and now I have this file called index.html. So you can use wget to pull things down from the web, and we'll do that occasionally to get extra data files and stuff that we can play with while we're writing various programs. So that's it for other commands. In the next video, we'll come back and we will see how we can stick these commands together with various redirection operations. So practice using these commands and internalize the ones that you use a lot. And that way you won't have to look them up all the time. See you again soon.